Now let's see how to do our calculation of our percent acetic acid in our unknown vinegar solution. First of all, we have our known solution in the burette, sodium hydroxide. Make sure you have this molarity written down. And then we also have our vinegar sample down here. We need to know its volume, and we will also be given its density. Okay, and our indicator is down there as well. So what you do is, before adding any sodium hydroxide, you take a reading, and then you start to drain that into your vinegar until your vinegar turns light pink. At that point, we know that we've reacted with all of the acetic acid, and it's starting to react with the indicator. So we must stop as soon as we see light pink, and then we'll take a final reading on our burette. Okay, and by this difference, we can know how much sodium hydroxide it took, which will tell us how much acetic acid must have been in there. So first, a volume of sodium hydroxide, we just take our final reading minus our initial reading. To get the volume of sodium hydroxide that it took to react with all of our acetic acid. Okay, how many moles of sodium hydroxide was that? This is why we needed to know our concentration or molarity of our sodium hydroxide. This means 0.5, that's funny, 0.541 moles of sodium hydroxide per 1 liter of the solution. And so when we come down here, we see the first thing we need to do is to change this from milliliters to liters so that we can use that molarity. Once we get to liters, we can use that molarity. There, and I am keeping more digits. I'm not necessarily going to write them all down, but if you leave them in your calculator, you'll get my answers. Okay, so that's the moles of sodium hydroxide that it took. So how many moles of acetic acid? Well, this is where we're using our coefficients in our balanced chemical equation. They react in a 1-to-1 mole ratio. In other words, the number of moles of sodium hydroxide at the equivalence point, which is approximated by our color change, the end point, is going to be equal to the moles of acetic acid. So in other words, we're going to use the same number here. Okay. Well, we want to know percent by mass of our vinegar. What percent by mass is acetic acid? So we need to get this moles to mass. Again, I'm carrying digits in my calculator. I may not write them down, so things won't quite look the same sometimes if you don't do that. So anyway, so this is moles of acetic acid, and we go from moles of acetic acid to grams of acetic acid using its molar mass. And I believe the lab manual just gives you 3 sig figs, so we will use just 3 sig figs here. 60.1. Okay, so now we have grams of acetic acid. Well, we also need the mass of the whole thing. That's the mass of the part. We need the mass of the whole thing. If you remember our vinegar solution, we had 20 milliliters. and we knew its density. Its density was given to us 1.06 grams per milliliter. Again, where we're getting this is the density of the whole solution. And so I get okay, and then to get the percent acetic acid in that, I'm going to do the mass of the acetic acid this is my more digits I had from above, divided by the total mass of the solution times 100. And that's about what the percent will be for vinegar. Certainly in quizzes and tests and stuff, we may give you solutions that are not 5%. But anyway, that's how you do it.